Hello, my name is Ege Ural and my department is Computer Science. Today I will be presenting my lab project for Physics 102 course where I investigated how electric current creates a magnetic field and how this field interacts with the Earth's magnetic field. The aim of the experiment was to measure the deflection angle of a compass placed at the center of a circular coil. Then, using the tangent galvanometer principle, to estimate the horizontal component of Earth's magnetic field. For this experiment, I used various simple but essential pieces of equipment. First, a circular coil made from a copper wire which generates a magnetic field when current flows through it. Second, a small compass placed at the center of the coil to measure the deflection angle. I also used a DC power supply to control the electric current connecting wires and a stand to hold the coil in the position. To begin the experiment, I have put the coil and compass were placed horizontally on the table, so the needle could rotate freely in the horizontal plane, and this ensured that the compass responded only to the horizontal component of the magnetic field, which is the part relevant for the tangent law. And also, after connecting the power supply, I gradually increased the current for each drill at every current level. I waited for the compass needle to stabilize before recording the deflection angle theta. I repeated this process for 10 different current values to obtain a smooth and reliable dataset. Once the raw angles were collected, I calculated the tangent theta. By using tangent theta equals to magnetic field of the coil divided by magnetic field of the Earth, I have calculated the magnetic field of the Earth. The result of my experiment showed a clear linear trend between tangent theta and electric current, confirming that the magnetic field produced by coil increases proportionally with current. Using the slope of the baseline and the standard formula for the magnetic field at the center of a circular coil, I calculated the horizontal component of the Earth's magnetic field to be approximately 14.6 microtesla. Although this value is quite lower than the typical range found in references, it is quite reasonable given the laboratory conditions. The environment contained metallic structures, electronic devices, and magnetic interference that affected the compass reading. Overall, this experiment helped me understanding how magnetic fields interact, how sensitive they are to external disturbances, and how real experimental data can be used to measure physical quantities. That's all for my lab project, Physics 102. Thank you for listening to my presentation.